Hi everyone, my name is Abhiraj Garikapati. Welcome to my YouTube channel Amazing Abhi. This is the capstone story for the whole foundation session. Instead of learning terms one at a time, we follow one simple action. An application wants to write hello world to a disk. That simple request becomes a journey through partition identity, the channel subsystem, a selected CHPID, a physical PCHID, a switch, a control unit, a device, and finally a completion interrupt back to the operating system. Before the journey starts, imagine a clean lab setup. A ZOS partition named ZOS1 is running inside CSS0. Two ficken channel paths are available, CHPID.2 and CHPID.21. They map to physical ports of M1 A control unit owns device 8001, and the root uses a link out and CHPID value to reach the right storage location. The IOCDS was already loaded at machine startup, so the channel subsystem has its map ready. The story begins at the top. An application says it wants to write hello world to device 8001. To the application, this feels like a simple request. It does not care about physical ports, switch routing, or control unit details. It hands the request to ZOS CO services, and ZOS submits the work to CSS0. Because the architecture is asynchronous, ZOS does not sit and wait. It goes back to other work while the channel subsystem handles the journey. Before we move ahead, please take a second to like on this video. A like tells me that you enjoyed this topic. Your support helps Amazing Abhi grow naturally. CSS0 now behaves like a smart dispatcher. It receives the device number and looks into the IOCDS-derived tables that were built at startup. It finds that device 8001 belongs to control unit 8000. It also finds that the available channel paths include .2 and .21. If both are healthy, the firmware selects one, such as 0.20, based on availability and path condition. Now the request is packaged for travel. Think of this as nesting envelopes. The outside envelope has the switch root, called the link out value. Inside that is the CHPID value that points to the right logical control unit in the storage system. Inside that is the device address, 8001. At the center is the actual data, hello world. Each layer will be used by a different part of the path. CHPID.2 is logical, so it must be mapped to something physical. In this example, CHPID.2 maps to PCHID.1. That PCHID is the real physical port where the cable is connected. The frame exits through that port, travels across the fiber cable, and arrives at the switch. This is where the logical root touches the physical world. Before we move ahead, please take a second to share on this video. Sharing helps this video reach friends who may also enjoy anime, gaming, travel, cricket, chess, career basics, or personal stories. Your support helps Amazing Abhi grow naturally. The switch reads the outer routing instruction, which is the link out value. If the frame says link out 3B, the switch sends it to the port represented by 3B. The switch is not judging whether the route was intended by the engineer. It simply follows the instruction. This is why a wrong link out value can be dangerous. A clean-looking configuration can still direct traffic to the wrong place. After the frame reaches the storage side, the next layer is used. The storage system reads CHPID.2 and routes the request internally to LCU.2. Then LCU02 reads device address 8001 and finds the right volume. The data, hello world, is written to that volume. What began as a simple application write has now traveled through the full logical and physical stack. Before we move ahead, please take a second to like on this video. A like tells me that you enjoyed this topic. Your support helps Amazing Abhi grow naturally. Once the write completes, the storage system sends a completion response back through the path. The frame travels back to the switch, back to the physical port, and back into CSS0. The channel subsystem marks the AO request as complete and posts an interrupt to the ZOS partition. ZOS receives the completion and tells the application that the write succeeded. Every major concept from the session appeared in this one journey. The IOCDS supplied the map. IML loaded that map. CSS managed the request. The LPAR issued the work. The asynchronous model allowed ZOS to keep working. CHPID provided the logical path. PCHID provided the physical exit. The control unit and device definitions identified the storage target. The link out and CHPID guided routing. The completion interrupt closed the loop. The final lesson is that ZIO is precise because every piece has a clear responsibility. The operating system requests work. The channel subsystem manages the route. The AOCDS defines the map. Logical paths are tied to physical ports. Switches and storage devices follow the routing information. Then completion returns by interrupt. When the map is correct, the journey is reliable. When the map is wrong, the machine still follows it, so precision is everything. If you enjoyed this video, please hit the like button and subscribe to Amazing CHPID. Subscribing makes sure you do not miss the next video, and it gives me motivation to keep improving the quality of every upload. Thank you for being here, and I will see you in the next one.